Welcome to Methamphetamine. Today we're gonna do the integral of sine square of lnx over lnx from 0 to 1. And this integral actually converges. So you can check the graph of this sine square of lnx from over lnx from 0 to 1. It actually converges. So how can we solve this integral though? First thing, we're gonna use our Friedmann technique. We let our I of something choose any variable you want, except for e and I. And I don't like e and I because they mean something, right? I means the imaginary number and e means the regular number. So avoid to use e or I here. So I would like to use a. I like a more. So I of a is 0 to from 0 to 1. Here's the deal. I would like to put an a here. A times lnx over lnx. Always the a is always gonna be greater or equal to 0 like that. Why I put an a here? Because it actually converges this integral. And this function just increase, right? Increase the value of psi. So a is greater or equal to 0. When we put 0, this entire you just get 0. So when you need to figure out what's the constant, so just put a 0 into the a, and it will be really easy to do. So we're gonna differentiate both sides with respect to a. So over, we're gonna differentiate the inside with respect to a. So over 1 over lnx is a constant in our a row. So put 1 over lnx in front and then multiply by, we're gonna differentiate this. First you get just with a 2 to here you get 2 and then minus the power you get sine times a lnx, and then don't forget to do a derivative of sine of a lnx. So this is cosine of a lnx like that. But don't forget about the chain rule. You're gonna multiply by the derivative of inside a lnx. In our a row, lnx is just our constant. So far, just get lnx. Differentiate a times lnx in our a row, you just get lnx here. Dx. So over, you see lnx and lnx, they cancel each other out. And here's the deal. We do not need to put the 2 outside, because 2 sine of something times cosine of something, it is just our sine 2 of something, right? So this sine 2 of 2a lnx like that. Dx. So over, you see, we're gonna integrate sine of something times lnx like that. Sine of something times lnx, it can actually be integrated. So here's the deal. It will be kinda complicated in this point. So first, we're gonna use our substitution. Choose a random variable like u is 0 to 2a lnx like that. Differentiate both sides, you get du is 0 to 2a is just a constant, so 2a times over x, right? When you differentiate lnx, you get 1 over x over, you get 2a over x dx. So what's our dx? So dx is just 0 to multiply by x on both sides. So what is our x? So over divided by 2a on both sides, and then with here on both sides, you get x is 0 to e to the power of u over 2a like that. So over this just e to the power of u over 2a, and then divided by 2a on both sides, you get 1 over 2a times that, and then multiply by du like that. So overall, you can put 1 over 2a outside the integral because it's a constant. So this is just 1 over 2a times. So what's our limit? Lower limit and upper limit. Put 0 into it. Ln, be sure a is greater or equal to 0. So over, you just get ln of 0. This is approaching to negative infinity. So negative infinity here. Put 1 into it. u over, you just get 0 here. The lower limit is negative infinity, and then upper limit is 0, like that. So over, this is just e to the power of u over 2a times psi of our u du. And here's the deal, e to the power of u over 2a times psi u. We're gonna do the integral of this first. E to the power of u over 2a psi u du, like that. Okay, here's the deal. We're gonna use our integration by part. Put the d and I here. And then we're gonna differentiate e to the power of u over 2a and then integrate psi u. Keep integrating psi u, you get, first you get negative cosine u, integrate this once again, you get negative psi u. And then differentiate e to the power of u over 2a in our u. So first you get the original one, and then 1 over 2a is just our constant. So 1 over 2a times u. Differentiate it, you get 1 over 2a, like that. And then differentiate this once again, you get e to the power of u over 2a, and then multiply by 1 over 2a once again. So this is just 1 over 4a squared, like that. So over this time, this is the first part of the answer. So this is just negative e times u over 2a times cosine u. And then this time that you get positive 1 over 2a times e power of u over 2a times psi u. And then minus, and then 1 over 4a squared is a constant, put it outside the integral. And then e power of u over 2a psi u du. So over this repeating situation, we can add this integral on both sides, you get. But don't forget, the original one is 1. 1 plus that, we're gonna get the same denominator, 1 plus 1 over 4a squared. So over you get 4a squared plus 1 over 4a squared, like that, times the integral of this. Psi u du is equal to negative e power of u over 2a times cosine u plus 1 over 2a times e power of u over 2a psi u. Be sure you should write it more clearly. Write a and u, you need to be more careful. So over e to the power of u over 2a psi u du. This integral is just, let me just flip, divided by this on one side, so over you just need to flip the fraction. So this negative 4a squared over 4a squared over 4a squared plus 1, and then multiply by e power of u over 2a times cosine u. And here's the deal, this multiply by 4a squared, you just get 2a, right? So over you get 2a, and then divided plus 2a over 4a squared plus 1 times e power of u over 2a psi u. So I would like to plus c here, never mind. So over these solutions is just 1 over 2a, and then multiply by this negative 4a squared over 4a squared plus 1 times e power of u over 2a times cosine u plus 2a over 4a squared plus 1 times e power of u over 2a psi u. This is really complicated, right? But be patient. So over, you can just multiply by 1 over 2a. Inside you get 2 and a, they cancelled. So over you get negative 2a over 4a squared plus 1 times e power of u over 2a cosine u. And then 2a and 2a, they are cancelled. So over you get plus 1 over 4a squared plus 1 times e power of u over 2a times psi u. And then don't forget, we're gonna put negative infinity and 0 into it. So the first one, if you plus 0, cosine 0 is just 1. And then e power of u, and then 0, e power of 0 is just 1. So over, you just get negative 2a over 4a squared plus 1, and then times 1 times 1, right? And then if you plus 0 into this, psi 0 is 0. And then e power of 0 is just 1. So 1 times 0, just over you just get 0 here. So never mind. And then plug negative infinity to here. E to the power of negative infinity times cosine of negative infinity. This is an indeterminate form, right? Cosine of negative infinity. So over we're gonna do our limit at x approaches to negative infinity, and then cosine u. I would like to put cosine u on the top, and then we're gonna put this on the bottom, but you need to change its power into negative u over 2a like that. So over, we don't need to do the what? We don't need to do the lost beta rule, because if you plug negative infinity to here, you get e power of infinity here. So over cosine of negative infinity is always between negative 1 to 1, right? So over 1, let me just consider this 1 over infinity, extremely big infinity. So over you just get 0, right? When a non-zero number divided by infinity or non-infinity, what is that called? Non-infinity divided by infinity. So over you just get 0. So over the situation of psi u is exactly the same. So limit x approaching to infinity psi u over e power of negative u over 2a. Sorry. So over this is also gonna be 0 as well. So over just minus 0 and 0. Never mind. So over this the 1. I power of a is equal to negative 2a over 4a squared plus 1 like that. So over we're gonna integrate both sides. I power of a is equal to that. So integrate both sides, get I of a is equal to. We're gonna integrate this. So if you don't know how to integrate this, let me just give you the step how to integrate this in our A row. So over we're gonna use up. Previous we let u is equal to that, right? So this time I'm going to choose another variable. Just don't repeat them. Just let w is equal to 4a squared plus 1. And then our dw is just equal to a It can, the number egg can be pronounced as many ways, but I would like to pronounce this as egg. But always I'm going to pronounce this as egg. dA. So for dA is just equal to 1 over a. Never, we don't need to do that because we need a on the top to get our dw. So multiply by 4 here, but don't forget to divide by 4. So over multiply by 1/4 here, and then the top you get dw, and then put a negative outside. So over this 1 over w dw. So over this is just negative 1/4 times ln of w is just 4a squared plus 1. And since this is always going to be positive, so just another absolute value. And also a is always greater or equal to 0. So over you just another. So it can be negative inside, right? So over this is just a solution. Let's see, negative 1/4 times ln of 4a squared plus 1 plus c, like that. So we need to figure out what's the constant here. So the constant is not always gonna be 0. So we need to figure it out. From 0 to 1 and the sine square of a ln x. I of a is equal to this, and I of a is also equal to this. So this and this, they are equal. So over, we're gonna choose a random variable. So we can choose infinity, because if you choose infinity, this just diverges, right? Don't choose infinity. And don't choose 2, 3, 4 because we don't know how to integrate it, right? 1. And don't put a is equal to 1 because a is equal to 1 is just the original we're gonna find. Sine square of Lnx over Lnx. 1 time Lnx, right? So why don't we just choose 0 here? Choose a is equal to 0 here. So over you get negative 1/4 of ln of, so 0 plus 1, so ln 1 plus c, and then from 0 to 1. So over this, put 0 inside, is beautifully just get 0 here, dx. So over ln1 is 0, so over you just get c is equal to 0. And because 0 it doesn't have the area, so over you just get the 0, c is equal to 0. So overall I of a is equal to negative 1/4 times ln of 4a squared plus 1. So original just sine square of 1 times Lnx over Lnx. So over the original question, sine square of Lnx over Lnx dx is equal to I of 1, right? Is equal to negative 1/4 times ln of, and then 4 times 1 square plus 1. So over you will get this is negative 4 plus 1 is just 5. Negative ln 5 over 4. This is really cool. This answers. This answers is about negative 0.402 like that. And if you put the answers of this integral on Wolfram alpha, it will give you these answers. It doesn't give you the expression of the ln, but it will give you this answer. So overall, this is the general formula. I of a is equal to negative 1/4 of ln of 4a squared plus 1. This is the general formula to find this, right? The area of the integral of this. So for example, 0 from 0 to 1 and the sine square of, let me choose a random number, just 2 lnx over lnx. So this is just I of 2, right? So over this negative 1/4 times ln of 4 times 2 squared plus 1. So over this is just 2 squared is 4, 4 times 4 is 16, 16 plus 1, this is just negative 7 ln of 17 over 4. And this is really cool.